Hi, we're doing Chapter 5, Section 3, Triangles and Quadrilaterals. I'm going to kind of look at, this section has a lot more like memorization probably, although I'm sure some of the stuff you know. But with these, we want to take and break them up into different categories based on their properties. So first going to look at triangles and kind of say, well, what three things are true about something to make it a triangle? So first thing, all triangles have to have three sides. And you probably learned that years and years and years ago. And then, so if they have three sides, they also have three angles or three corners or three vertices. And if you add those together, they should add up to 180 degrees. So if it's addition, we call it the sum. So the sum of the angles equals 180 degrees. And now we have different ways to classify them. So my third point is different ways to classify. Really, we're talking about ways to break them into groups. So like in our classroom, you could break people up into like teachers and students, or boys and girls, or something like that. We're going to do that same sort of thing with triangles. So the first way is going to be by the number of congruent sides. And congruent is really just the geometry way of saying equal. But we'll say congruent instead of equal when we do geometry sort of stuff. So this first example right there is going to be a scalene triangle. In a scalene triangle, you'll notice that all three of the sides have different lengths. So all three sides have different lengths. Or if we wanted to go through and classify it kind of using that congruent, you could say no two sides are congruent, that all three are different. Isosceles, you'll notice on this next one that the two vertical sides look to be the same length, so that one and this one right there. What they often do to note that is they'll put like a hash mark that's perpendicular to the edge, usually in the middle of the thing. So that's trying to say that, hey, those two sides are congruent. So isosceles, that's going to be a triangle with two congruent sides. And I'm probably going to start using the notation. That congruent, what they do for that is it's an equal sign with a tilde. Remember that tilde from Spanish class? So congruent is going to be that sort of thing there. And the other thing that you'll notice is that we also have two angles that are the same. And that'll be true for every isosceles triangle. So if you wanted to, you could say, and two congruent angles as well. Now, an equilateral kind of has that word equal in there. So equilateral is going to be where three sides are congruent and three angles are congruent. So this here, all three of my sides are the same length, so I could do the hash mark on all three sides. Equilateral, it's going to be a triangle with three congruent sides. And just like those sides are congruent, the angles will also be congruent. Oh, notice up here. My and was just an and, so that should have been an and two congruent angles. So you could say and 3. Well now, if the angles are congruent, so all the angles are the same, and they have to add up to 180, that can tell us what the actual angle measures are. So what number plus itself gives you 180 degrees? That'd be 60 degrees. And three 60-degree angles. So equilateral triangles, all three of these angles are all going to be 60 degrees. Now maybe even write that in, so 60 degrees. So that's one way to break triangles up into groups. But we also could do it based on like what their angles look like. So we could look at their sides, or we could do their angles. So if we classify them by angle measure, in acute you'll notice each of those like, oh, cute little triangle. So the angles are all going to be less than 90 degrees. So all angles are acute. And by that we mean less than 90 degrees. So less than 90 degrees. So there's an example there. If we have a right triangle, so a right triangle has a right angle, and a right angle is going to be this one down here, that we have a 90-degree angle. So with this then, it'll be one 90-degree angle, so one 90-degree, or I'm going to put right in parentheses, angle. And if the triangle has to have three sides and three angles, and it has to add up to 180, well, if one angle is 90, then the other two have to be less than 90. So it's only possible to have one 90-degree angle there. So once you get that done, you can flip to page 2. I'm going to keep scrolling down where I'll hit my page 2. The third way we could look at it for angle measurement is going to be obtuse. And an obtuse triangle, switch back to a pen. So an obtuse triangle is going to have one obtuse, and that means greater than 90. Angle. And that right there is our culprit. That big one there is going to make it an obtuse triangle. And again, if they add up to 180, you can only have one obtuse angle in an obtuse triangle. Alright, so that's what we have so far. That's done with the triangles, the three-sided. Now we're going to go into quadrilaterals. Maybe you think of like a quad runner or something like that. We're going to do the same thing with quadrilaterals, well, four-sided figures. How do we classify them? How can we break them into groups and so on? So quadrilaterals, that quad then tells us 4. So quad, so that means 4 sides. So our first one then is going to be, first bullet point, it's a four-sided figure. You could say a four-sided polygon if you wanted to. The edges will all be straight. It'll have to be enclosed, has to have 4 sides. Okay, the other thing then we could say about it is the sum of the angles. Well, if you take any four-sided object, I'm going to take this one. I wouldn't draw this in on yours, but you agree I could take and turn it into 2 triangles. So if this angle, this angle, this angle are 180, this, and this are 180, if you take and combine all those together, 180 plus 180 gives us 360. So the sum of the angles is 360 degrees. And that'll be true for any four-sided object or any quadrilateral. Now we want to go through and start breaking them up. So I have trapezoid still on this page. And trapezoid's kind of a strange beast. It's separate from the rest of them. So because it's a quadrilateral, we know it has to have 4 sides. So I'm going to write that down. And we also could say one pair of sides is parallel. And I think they do like this symbol for parallel. I remember back to my days in geometry. So only one pair. Yes.
We need your help. The
Okay.
speakers aren't working.
You're back. Alright, so now we could flip to the next page where now I have them kind of in a big, arrangement. So all these are going to be parallelograms, but then parallelograms can be broken up into rectangles and rhombuses, and then a square kind of relates to those. So that's kind of why I have this strange configuration on page 2. And for something to be a parallelogram, something has to be true. Basically, it has opposite sides are parallel. So parallelogram, opposite sides are parallel. So you'll notice this side and this side are parallel, and this side is parallel with that side. So that's going to be one thing. And 2, opposite sides also are congruent. So maybe I should put a little colon there. Opposite sides are parallel, and opposite sides are congruent. So a parallelogram is going to look like that there. Basically, it's a square that kind of got pushed on and kind of like forced to the side one way. So that's true for those. Now, but I suppose not always. I maybe shouldn't have said that, because next thing, if we go down to a rectangle, you'll notice a rectangle fits that. Opposite sides are parallel and congruent, so those two are the same length and they're parallel. These two are the same length and parallel. But for each of those, though, try to erase all that, for each of those, the angles now are going to be 90 degrees. So a rectangle is going to be a special kind of parallelogram where all the angles are 90 degrees. So it's a special parallelogram, and I'm just going to write 4 90-degree angles. So 4 90-degree angles. And if you wanted to, you could go through and put in your little right angle symbol in each of those corners. Nothing wrong with that. A rhombus looks more like the parallelogram up above. So maybe I should mention a rectangle now is a parallelogram as well. So if you get a rectangle drawing that says, well, what groups is it in? It's a rectangle, it's also a parallelogram. A rhombus is where we have not 90-degree angles. So this one here looks a little bit more like the one at the top of the page. You still have opposite sides that are congruent, they're the same length, they're parallel, but you don't have 90-degree angles. So this here is also a special parallelogram. But now, what makes it not just like the one above, what makes it actually a rhombus is going to be all four sides are congruent. So not every parallelogram, this one up above, is a parallelogram, but it's not a rhombus because it doesn't have all four sides that are congruent. But any parallelogram, like on the top, any rhombus, like on the bottom, rather, is also going to be a parallelogram. Okay, now if we take those two and kind of combine them together, we combine the 90-degree angles from the rectangle that shows up here in this square drawing. But now if we have all four sides congruent, and I maybe should have when I did the rhombus, done like the little tick marks to show, hey look, all four of those sides are congruent. The same is true with a square. So a square now is a special type of quadrilateral in that it's a square, but it's also a rectangle. It's also a rhombus. It's also a parallelogram. So it's a quadrilateral that fits in all kinds of different ones. So a square, we could say all four sides are congruent. Woo, killed that drawing. So all four sides are congruent. Like the rhombus, but you could also say all four angles are 90 degrees. And that right there should finish up the whole chapter. Let me just scroll down. Yep, so there's all my learning targets. So like I said at the very beginning, this section here might require a bit more work as far as like memorizing stuff. I think a lot of it you know, but it's worth looking over the stuff especially well before a quiz because it can jump back and get some people on the quiz. Let me know in class if you have any questions.